Okay, so let's have a look at this example from the module on the ambiguous case. Now, I just want to highlight here, you're given triangle PQR, you're given one angle, and you're given two sides. You always start by asking this question. Is the side opposite the given angle shorter than the other side? Well, how are you going to figure that out? Look at the picture. The side that's opposite the given angle is 11.3, right? It's directly across from 29 degrees. Is that side shorter than 15.6? Absolutely. So this is definitely the ambiguous case. How do you go about solving an ambiguous case and ending up with two triangles that's shown below here in white? Well, what you'd want to do is with your pencil, and if you follow the cursor here of my mouse, pretend like I was going to draw a line from Q straight down to the base of the triangle. That would be the height of that triangle. And that's what you need to figure out. So this calculation that you see down here, r sine theta equals 15.6 times the sine of 29. That height, which equals 7.563, this is the height of that triangle, which you can compare to that shorter side, that 11.3. And when we compare that, we obviously realize that 11.3 is a lot bigger than this height, right? You always find the height the same way, r sine theta, where r is the longer side, 15.6. So we figured out that it's the ambiguous case. 11.3 is much longer than this height that I calculated. So the resulting two triangles will occur because I can take that 11.3 and draw it in two places. So that's why we end up sort of splitting the triangle into two possible cases. Follow the cursor on the screen here, P, Q, R, and back. That's one of the two possible triangles. And you see that triangle down here, the one I'm circling. The other possibility is PQR being placed closer to P. That's the second triangle, which you have here. And that occurs because of this ambiguity, the ambiguous case of having this equilateral triangle, an isosceles triangle here. These lines, the 11.3, can be in two places. You don't know which place to put it, and so we have to look at both triangles. You don't have a choice. You have to run through the sine law twice. So I recommend drawing out the two triangles, the ones you see here in white, and then do the calculations with your calculator. I know that doing the sine law is old and you've done it lots of times in other math courses. The hard part is getting to these two triangles. Once you're here, you run through the sine law as you would before. So that's what's shown above here with all of those calculations. Try to approach these problems that way. Go through this example again, starting from the top, and read what I've written down here. After that, try the practice exercise, get this sheet downloaded, and I've provided another video that I want you to have a run through.